So today we're going to be talking about growth and decay. Again, we're going to be doing applications of that. I wanted to clarify one thing, and I'm putting this in the video on purpose from yesterday. I did not do a good job of teaching this to you with growth, decay, and common ratio. We had questions about the whole situation where what if it's u sub n is equal to u sub n minus 1, but then it's just like some of our first examples, it's just multiplied by 3. What does that turn out to be our percent change? What I told you yesterday, and I feel terrible about this, was wrong. So this is your actual percent change. So basically, it's always going to be 1 plus that percent change. So like with our example that we did yesterday where we said 3 multiplying by 3, that would be 1 plus 2. So then our percent change would be this 2 or 200%. So I want to be sure and clarify that. That was something that I did wrong yesterday, and I discussed it with a couple other people because I felt a little shaky on it, and just want to be sure and clarify that. So basically, for your growth or for your decay with the percent change, it's always going to be 1 plus that number, because then it's always going to be different than your common ratio. So with this one here, your common ratio would be 3. It's always the combined number inside of that parenthesis. Your growth or decay is always going to be 1 plus that percent change, so all we care about is just what that percent change is. It's just that piece there. So I want to be sure and really put that out there, really put that firm, and definitely wanted to apologize for that. I feel bad about that. So yeah, that's the first piece. I'm sure that you guys are wondering about this joke, so I made sure to know the answer. Does anybody know the answer on why lobsters don't share? Finn, is that a hand? That's close. They're very shellfish. Ah, so there's your joke for the day there. Very punny, very punny. So. All right, so this is the type of stuff that we're going to be looking at. Will be like mortgages and whatnot. Just kind of wanted to throw out something onto the radar so that you can kind of see in a quantitative way, because we've all heard about this this finance drop that happened in the kind of 2008 to 2010 range. So this is a price as of January 2016 on this house here, $550,000 roughly. So looks like a real nice house. The thing that's really unfortunate about this is this part right down here. So back in April of 2004, this thing sold for $735,000. So bit of loss, a bit of decay in that value. Just something to point out, to kind of see some numbers there. I thought it was just kind of a fun piece to throw in there. Well, not fun for them because they lost $200,000. That sounds awful. But yeah. So moving ahead here, we're going to do an example. Like I said, it's going to be a lot like what we did yesterday, but we're just going to do more examples with that. So this will be our first example here. So why doesn't everybody pull out their calculator? And I'm going to pause the video here while we do that. Okay, so now everybody's got their calculator out. We're going to go through that process again of how to enter this back in, just in case we had to reset our calculator for science class or something else like that. So our first step is we just want to get everybody to square one, so we're going to reset the RAM, and I'm going to have the keystroke history here. So if you miss something, just look over on that screen right there, and you'll be good to go. But it should be second, then the plus sign, and then 7, and 1, and then 2. And once that resets, you should get some sort of a screen that looks something like that. So we're all back to the same page there. Once everybody's done that, the second piece of it is we're going to go into the mode, and we're going to go down to the function, then go over and do sequence mode, because we want to be in sequence mode. Don't go down to this sequential, that won't work there. We're looking for that line that's got function, parametric, polar, and then sequence. So if everybody's there, when you press the Y equals screen, it should pull up something like this. Why doesn't everybody turn and look at their neighbor? Make sure that everybody's on that same screen there. All right, so moving ahead here, we're going to take a look at this example that is right behind here. So this example is saying, in 2006, in a small town of population of 1,500, it is predicted that the population is increasing 3% per year. So we're going to write a recursive formula to model a situation. Then we're going to find out what the population will be in 2020 and when the population will reach 5,000. So let's just start just with this first piece here, and let's have everybody take a second and try to write that formula, and then we'll put that formula into the calculator as a separate piece. So let's just start with writing the formula. Give you a second to do that on your own. And then, so we're going to take a look at what that formula is here. So it's saying that u of n is equal to u of n minus 1, because this is what we're always going to start all of our formulas that's how we're always going to start our formulas. And basically, this is just saying, this is recursive, so it's saying that u of n is just dependent upon the previous term. And then we're going to multiply that, because this is a geometric. It's increasing by 3%, not by a constant number each year, like an arithmetic would be. This is a geometric. And it's increasing by 3%. So we've been doing it like that there. So it'd be 1 plus 3%. And this is just the decimal equivalent of 3%. And then, of course, we need our last pieces to it as well. So we go u of 1 is equal to 15,000. In fact, in this case here, I probably wouldn't do u of 1. I would do u of 2006 exactly. So u of 2006. And this is where it's equal to 1,500. This is where those different starting values. So then, with it being u of 2006, what do you remember about where n needs to be on this? 2000 and, I heard it down front here, 2007. And why is it 2007 and not our normal 2? Because it's always one more. Yep, because it's dependent upon the number in front of it. So now that we've got our formula here, let's put that into the calculator. So we'll jump back over here. And remember that this first one here is the n minimum. So in this case, it's not going to be 1. It's going to be what we just talked about, 2006. Because this number here is just asking for what is our number that is right down here. And that's usually 1. Most of our examples so far have been 1. It's our first example that we have that it's going to be 2006. The reason is it'll just make it easier for us to see what's the year 2007, what's the year 2008, what's 20 years from now. Yes? So the ratio, the common ratio would, you don't necessarily need to know that for this style of a question. That's usually that you see that more when it's actually like sequenced out as far as numbers, but you still could find it. So the common ratio we know is this whole term here. So would that be 1.03, that's the common ratio? Yes. Yep, so the common ratio would then be 1.03, and then I think going off of my my mistake from yesterday, this isn't a great example of showing that, but our percent change, then what would our percent change be on that, just as a good little review piece here? Percent change would be 3%. Yep. 3% would be the, let's call it the percent change there. So just a good little review from yesterday. Okay, so moving forward here. So this is our first line, 2006. Then our second line is we want to be able to put this part of the equation into the calculator. So going down here, remember that our calculator can't do subscripts, those small n's. So when it is doing a subscript, it's doing it in a parenthesis. So we just go here and want to tell it u of n minus 1, because that's always how our formulas are starting here. They're going, so far we've got u of n. Now we just want to input this part, u of n minus 1. So going back to the calculator. So the u is just the second key and then the 7, because it's above that 7. So u of, and then we're doing those subscripts. So we go parentheses, u of, and then n. It's the same thing as our x key now, because we're in sequence mode. So u of n minus 1, close that parentheses. Be sure that when you put the minus in that you're doing the minus key. Don't do that key, because that thinks that it's saying n negative 1, and it doesn't know what to do with that. But if you press that, it'll know what to do with that because that's n minus 1. So all we've got so far here is we've got this chunk of it right here. So now we just need to do this last piece in there. So multiplying by 1 plus 0.03. And I know that's an extra keystroke to do that multiplication, but it'll help you out. So 1 plus 0.03, and that's just multiplied by. And then what's our last step here? Who remembers our last step? I am going to take the hand here. Yes. The U of 2006. Yep, exactly. So our U of 2006 here, our starting population, 1,500. So that's all that we're doing. Let's put in 1,500. And then we can go ahead and we can figure this out. What will the population be in 2020? So we have two ways of doing this. First off, let's take a look at our table. You can already see my table here because I want to show you a little thing here with the table. A whole bunch of errors. Why am I getting errors there? Because it's 2006. So I don't want to arrow all the way down to 2006 because what if I need to see a table of values? Well, I just need to set my table then to basically see the values that I want to see. So above this window key is table set. So second table set, and then you can set your table start. So in our case, we want to start in 2006 because that's the first piece of data that we have. And then from here you can say you're changing the table values. So I could have it go by 2s or by 5s or by 10s or basically some other thing. But I'm going to go by 1s because I want to see each year. And then last piece. So now this is all set. And I'm just going to go back to my table. And there we have it. So we can see our first year is 1,500. Our next year would be 1,545, and so on and so forth. But instead of having to go all the way down and figure out what 2020 was, who remembers the trick that we could do instead of using the table? Yes? Yep. So second quit and just tell it, hey, I'm looking for U of parentheses to get it down in that subscript. I'm looking for U of 2020 because I want to figure out what that population is, and pulls it up, and some poor soul is 0.88 of a person. So being that this is just more of a statistical thing, of course 0.88 of a person would not exactly be much of a person. So but since it's just stats, we just round that off. It's just giving us an estimate. So this is what our 2020 population would be. Something around about 2,269 people if you are rounding up from there. Our last piece here is, this is where that table set will be helpful. Let's push that up a little bit. When will the population reach 5,000? Unfortunately, there's not an awesome way to just tell the calculator, hey, put 5,000 here and then figure out this stuff here. So that's where your table set is going to be helpful. So we can see that it's increasing kind of slowly there. Oops. Let me get back into my table here. So we can see that it's increasing kind of slowly. It's going to take me a long time to arrow down to find 5,000. So what I would recommend doing is I would change my table set. Let's have the table set start at, say, I don't know, so have it start at the year 5,000. Okay. Well, let's see what the year 5,000 gives us. Second, table. You freaked it out, Tor. Uh-oh. Got out a little bit too bold here. Might have to quit, see if I can get it to... Oh, you can change the table. It's loading. Yeah, it's still thinking. Right, I'm going to pause the video. Let's not do 5,000, because that kind of freaked it out. Nope, that's not what I want. This is what I want. Okay. Did I hear a number that I should be? 2,047. So let's just go let's go 2040 just to see some data before that. So 2040 will be our table start. And then just jump over here to the table. Hopefully it thinks a little bit happier this time. There we go. So it looks like in the year 2047 here, let's get this into the video. All right, now that's in the video. The year 2047 looks like it's the first time that it breaches into the 5,000 mark there. So that'd be something right about there. Now, could we guess that sometime in 2046, the population probably was above 5,000? Sure, but we don't actually know that. So this would be your correct answer here, because we don't actually know exactly when. We don't know when they're doing this analysis. Like, what if they're doing it, December 31st, so the last day of 2046? Well, then for sure not. It didn't break into the population by then. So that's why you always want to go with that number when it's saying will be above that. So that's our first one. So it's really just doing the exact same thing we did yesterday. If you felt confident in this one, you got everything that you needed from yesterday's lesson, and we're just going to do a couple more here. Before we move ahead with that, because I feel like everybody is getting that, I want to do one more thing. Going back to my mistake from yesterday as far as percent change stuff goes, let's do one of those and take a look, and let's make sure that we caught up with what I said is the difference from yesterday to today. So basically, let's do this one. So u of 1 is equal to, we'll call it 1,000, and then we'll say u of n is equal to u of n minus 1 multiplied by, we'll say multiplied by 4. And I'm making this intentionally a little bit difficult. So what would be my common ratio, and what would be my growth/decay rate? And of course, I would need my n is greater than or equal to 2 as well. So get both of those, and then once you have those, turn them towards me so that I can take a look and see, make sure that my error is not causing you to make errors. Don't let my mistakes become yours. So who can help me out here? I'm going to take Mr. M down front here. What did you get for your common ratio? You got 4. And why'd you get 4? Because that's what's in the parentheses, and that's what's in the whole parentheses. What'd you get for your growth/decay rate? 300% would be the correct answer, because we want to translate this into 1 plus 3, and just plug that in right there. And then this number here is always going to give us what the rate is, and then this here is telling us if it's going to be growing or decaying. So, yes, sir.
Will there be something where it declines 300%, negative in the parentheses?
Well, let's answer. Well, this wasn't quite 300% like that house that we looked at. That declined a huge amount there. So you might see something like that where it goes the opposite way. Let's actually take a look and do one of those there. And then was there another question over here, or is it along the same lines? Okay, yeah, sure. Let's do one of those. So same thing. U of 1 is equal to 1,000, and then u of n is equal to u of n minus 1, and then we're going to say that that's all multiplied by negative 4. Let's not do 4. We just did 4. Let's do negative 3, and being greater than or equal to 2. Same thing. We are looking for our common ratio, and we're looking for a growth/decay rate. Once you get that, show that to me there. Awesome. Yes, so I'll do this one here in just a second.
absolute value or no?
What's that?
When you're, is the common ratio absolute value or is it just
Yes, sir.
can it realistically
Yes. Yep. Yes. Yes. So, yes. All right. All right. So bringing it back in, bringing it back around here. Uh, let's take a look at this. Just a second here, guys. We'll go through this problem right now. We'll go through this problem right now. So, pretty easy one. What's the common ratio? -3. We all agree on that. That's easy. That's just the whole thing inside the parentheses. Now here's where our question is. What is the growth/decay rate? This one we know since it's a negative. It's a decay. That's fairly obvious. What do people get for your decay rates? 400% is what I'm hearing. So based off of our, I didn't necessarily state that was correct. I just wanted to. So sometimes having some difference is great because then you can get a chance to learn. It's not embarrassing. This is a new concept, and I instructed it wrong yesterday. It's not crazy that somebody got a wrong answer. So yeah. So going back here for decay, it's always going to be 1 minus the percent change. So since we always need this out front, the 1 minus, what is going to make this, let's see, we're right here. What's going to make this go there? So that'd be 1 minus -4, because that result there is going to give us -3. So that's why our rate ends up being 400%. You have to be able to get to, well, it does matter if it's addition or subtraction, because if you, well, it does matter because long story short, the negative or the positive is what's determining if it's growth or decay. But both sides of that statement, there could be things that are right about it and things that are wrong about it. Because in theory, it doesn't matter if it's plus or minus because you qualified that by saying with that 1, but it does matter whether it's plus or minus because that's determining if it's growing or shrinking. But long story short, you need this to be mathematically correct. You need this to add up or subtract up to what your common ratio is, and everybody feels confident with common ratios. Yes, sir? If it was 1, yes, then the growth rate would be 400, whereas this is the decay rate. So that's dropping versus increasing. But yes, that is exactly correct. Yes, sir. -400%. In theory, -400%. Since I labeled it as being a decay rate, you would know to put that negative in there. But I mean, if you put -400%, I would be totally fine with that. That's a correct answer. So both of those options are both good. All right. Do we feel confident about percent change and decay rates? Awesome. Okay, so let's move on to our next example here. I'm just going to do one more, and then we're going to take a look at our homework. So example 2. Car loses 1/8 of its value each year. If the car costs $23,999 when it is new, write a recursive formula, then find the value in 6 years. So I'm going to let you guys just go and run with that and see what you get. Once you get there and you think that you've got your answer, compare with the person diagonal from you. And yeah, I'm changing it up and not just going across, going diagonals. And so as much as that makes sense, if you need groups of 3, do groups of 3. Take a look at that and compare with the person next to you and try to figure out what you did right, what you did wrong. All right, so bringing it back in here, we're going to take a look at this problem right here. Let's bring it in here. Let's bring it in here. So our first step is we're going to be looking to write a recursive function. So our first step is we're going to be looking to write a recursive, I said function, but I meant to say formula. So what do we think we should get when we write this recursive formula? Does anybody want to help out or be brave enough to jump in on this? Tor does. Yes, go. Yeah, tell me what you got.
I had u with n minus 1, or u n
Equals un minus 1. That's how we're always starting. Yep.
Yeah, and then I had 1
Mm-hmm.
minus.
And I'm guessing that's multiplied by?
Yeah, multiplied by.
Yep, 1.
Minus
0.125. And then the other couple of pieces with the formula. What are those guys?
You mean like the CR and stuff?
No, I'm talking about your starting value in your domain and whatnot.
Oh, I had my starting value at 22,900.
Okay. And what'd you put for the u sub something?
U sub 1.
Okay. So torted u sub 1 is equal to this 23,999. Just a quick little insight here. I would probably start this at u sub 0 because then by the end of year 1, I'm on 1. I'm not u sub 2 when I'm doing 1. So that's a little piece there that I'd probably change. And then my n would be greater than or equal to. What would my n be greater than or equal to with this guy? It would be equal to 1, exactly, because we're starting at 0. So that's just a small little catch there, but it'll just make your math be a little bit easier to read the table. I saw a hand over here. Yes? 0.875 versus 125. That's a good question. Who else got 0.875 instead of 125? So if the car is losing 1/8 of its value each year, what would our common ratio be? What would our common ratio be? So our common ratio. So let's say that the car is worth $1,000, and it loses 1/8 of its value. So if we multiply that by, we multiply that by 0.125. Is that going to be 1/8? That's 7/8. Right. So we want the common ratio. We want this thing to multiply out to 1/8. So what is 1/8 then? So 1/8 should be 1 minus 0.125, or the decimal equivalent there would be what, 0.875? Because that would be 1/8 there. Does that make sense? Or it's being multiplied by 7/8, but that's making it lose 1/8 of value. Does that make sense? Yeah. It doesn't. Yes. Talking about what doesn't make sense about that.
Well, I get that, like, it's losing 1/8, but isn't what is in the parentheses supposed to equal 1/8 in the end, correct?
Not necessarily. This is just how this question is phrased, which is why we're doing this one, is that it won't always tell you in the question what the common ratio is. In this case here, it's telling us what's our percent change. Our percent change is 1/8. Yep. Does that kind of make sense? So yeah, it's basically telling us the percent change instead of telling us the common ratio. Most of the other questions we've done so far, they've always started off with our common ratio, but that's exactly why we're doing this one, because we want to see those tricks that they're going to try to pull on us. So the car is losing 1/8, and just the best way to kind of ensure yourself safety against that is figure out what is 1/8 of the value lost off of something, like I did here, and choose numbers that you can quickly find and go, okay, times by 0.125, then all of a sudden I'm down to, $125 in 1 year. That's clearly not 1/8. So, but 0.875, I'm down to $875. That looks a lot more like 1/8. So, and it looks a lot more like it because it is 1/8. So, just that's a trick there too. There's nothing against kind of changing the numbers to kind of figure some stuff out or trying it in different ways and then going from there. So, Good questions, good questions. These are good questions. This is our first time seeing something like that, so I'd expect questions. All right. So knowing that, what do we find for our value in 6 years? Second piece of this. What's our value when it gets to 6 years? Can you say that a little bit louder? 10,771. Who else? Wait a second. Wait a second. Wait a second. Hold up. Hold up. Hold up. So, sounds like we have some dissension on things. So let's do it. Let's plug this into our calculator. So jumping over to our calculator here. We want to put this in. So the n minimum, that's our first step. We want to be sure and get that to 0 so that we can figure out the years easily. And then we've just got u of n is equal to u of n minus 1. Then we've gotten this piece here. So we've got 1 minus, because it's depreciating, 0.125. And our starting value is what? 23,999. Oh, thank you, thank you. That would have been another calculator restart for sure. All right, let's see here. Insert. So close to the bottom. Point, and of course, minus point. Awesome, great. I make mistakes too. So let's take a look at our table here. See what this will tell us here. Oh, you know what? I didn't change my table set from last time. No. So this is going to be real mad at me. But yeah, whose calculator looks like this here? Awesome. And then what'd you get for your value of 2006? Or for 6 years, I should say. Okay, so basically Tor just rounded this guy off. Just 70.63. So yes, so long as your calculator looks like this and you don't have to mess with your table set, that's what's going on here. This is just trying to plot something else. We have just a couple of minutes left here, so let's quick open up the homework from that's going to be for tonight. So jump into Schoology. And let's pull that open, and we'll take a look at what's going on there. Growth and decay applications. Should be 9.3 growth and decay applications. So here's what we're going to do. I'm going to quick let you know which ones we're going to do here. So real quick, the questions that we are going to do. We're going to do number 1. We're going to do number 1. We are going to let's do number 3. And let's do number, I think that's 5 there. So 1, 3, 5. Let's do 1, 3, 5, and 7. So do the odd numbers. It's just 4 problems. And then lastly here, we're just going to look at this one quick. We have just a couple minutes here. Suppose the recursive formula for u of 0 is equal to 1, and un is equal to 1 minus, and this, they just move this, that can go there, is equal to 1 minus 0.20, where n is greater than or equal to 1, models a bouncing ball. Give real-world meanings to the numbers 100 and 0.2. What do we think 100 is representing in this question here? What is 100? So this is a bouncing ball. 100 might be what? That's a good idea, but the height, yes. So 100 would be the height. H-I-E? E-I? Height? E-I. Thank you. This is why I'm a math teacher, not an English teacher. So, all right. So, so the height, and then what might this be here? The rate at which it is dropping is a perfectly great answer. You're doing the odd problems. Odd problems. Thank you.